Today, I will talk about a deep dive into Kotlin DSL. Let me introduce myself. I'm Junpei Matsuda, and my handle name is Dharma. I'm working at Delegate as a software engineer. As for JVM projects, I'm currently developing Android applications, Android SDKs, Scala server-side, and Gradle plugins, including side jobs. Of course, I'm using Kotlin. I've been using Kotlin for about 5 years, so it's since milestone 10th. This presentation has 3 aims. I would like you to know what DSL is and what Kotlin DSL is. And also, every audience will know what Kotlin specifications and or features support Kotlin DSL. Third aim is that you will be motivated to develop your original Kotlin DSL and or extend libraries by Kotlin DSL, hopefully. Before going to the main content, let me ask several questions. Who thinks Kotlin DSL is for Gradle? Oh, looks fine. In general, Kotlin DSL doesn't mean only Kotlin DSL for Gradle, and also in this presentation as well. In the following slides, I would pick up Kotlin DSL for Gradle as one of real examples, but I will not focus on Gradle's one. Okay, next. Who have used and or who are using Kotlin DSL? Okay, who know what techniques will help Kotlin DSL? Only one person? So let me ask a few questions more. Who can explain the definition of Kotlin DSL? Okay, who can explain the definition of DSL? Okay, I prepared these slides, but maybe no one could say yes to your question. So, no one is already Kotlin DSL developer. Anyway, okay, wrap up the introduction. Let's go to the main contents. Today's agenda is like this. First, I will explain the basic knowledge of DSL. After that, I will introduce specifications and or features, techniques which support Kotlin DSL based on levels. Finally, I will show quick tips for DSL development. First, we should know the general definition of DSL. DSL is a domain-specific language. A domain-specific language is a specialized computer language for a particular application domain. It's really a simple definition. In contrast, there is a general-purpose language like Kotlin and Java. By the way, what's the motivation to introduce DSL? Why people need DSL? I know there are so many reasons, so let me pick up a couple of them. In general, we use DSL to simplify complex code. DSL allows human readable names, domain knowledgeable names, and fluent style while writing code. And also, DSL often provides a clear and useful API for the domain, and or only required APIs for the domain. DSL would be our help when we would like to improve productivity and or reduce human errors. For example, if a domain does not have tools like any type checker, DSL's type system will help us. The left figure shows code to build HTML DOM tree, but it's terrible. if we introduce DSL, it would be it would be like the right figure. It looks well structured and similar to dormitory structure. In this example, the benefits to introduce DSLs are clear. As I said before, the definition of DSL was really simple, so it was interpreted broadly. Therefore, I would like to borrow DSL categories, external DSL and internal DSL from Martin Fowler. External DSL is a language that's parsed independently of the host general purpose language. Internal DSL is a particular form of API in the host general purpose language for the domain. In fact, we have seen many real examples for your development. For example, SQL, CSS, regular expressions are good examples of external DSL. For internal DSLs, we know HTML, mock library, DI container. And also, Kotlin DSL is an internal DSL. Internal DSL is based on the host general purpose language, so Kotlin DSL is not a special version of Kotlin. It's just a Kotlin code and built on several techniques and constraints. Basically, techniques for internal DSL depend on the host general purpose language. For example, it's type checking, base syntax, syntactic extensions, compiler extensibility, and compiler interpolation. For Kotlin DSL, it uses Kotlin, of course. Types are checked from calls at the compile time. And also, we can use Lambda expressions and so on. Kotlin has extension method, operator overloading, and extra for the syntactic extension. The compiler system of Kotlin is extensible through plugins and some built-in features which interpret the compiler. Let's take a look at an example. Kotlin X.html package is it. Kotlin X.html package is one of Kotlin DSL for HTML domain. It can generate DOM tree from Kotlin code. You can do it type safely, you can avoid typos, and you will not forget closing tags anymore. This small example includes some techniques of what I will explain. Okay, so let's look into what specifications and or techniques support Kotlin DSL. I categorize techniques of Kotlin DSL into 3 categories for their explanation. They are getting started level, intermediate level, and expertise level. Let's begin with getting started level. We will know language specifications which support Kotlin DSL, and you will be able to create a simple Kotlin DSL based on them. I have picked up type system and several specifications which relate to syntax. Kotlin uses static type checking, which is a code analysis-based type safety verification. In contrast, dynamic type checking is a type violation at runtime. Static type checking allows no type violations before execution. if you write a DSL in Kotlin, then you can get the benefit of this type checking. Let's see a simple example. This example is in Groovy. Groovy uses a dynamic type checking by default, so no error from the compiler will be shown, even if we use undefined methods. Of course, ID can show a warning. However, if we run this, it will fail at runtime due to missing methods. For Kotlin DSL, the compiler can know there is one unresolved method at compile time. So we can see a compilation error, and it's not executable code. This is not syntax stuff, but Kotlin DSL's power, certainly. Second group of language specifications is for syntax-related specifications. There are Lambda expressions and function literals with receiver. Lambda expression improves the expressiveness of Kotlin code. For DSL, Lambda expression is kind of a syntax sugar for function time variables and single abstract methods. It allows represent a function by braces. Let's say we have a method which returns a transformed string, accepts a string parameter, and a builder function for string builder. We can call this method like the figure below. And also, Lambda expression allows place a Lambda outside of the parentheses if the last parameter of a function accepts a function. Like this. In this example, string Kotlin is passed as a prefix and append fest to string builder. So the result value is KotlinFest. If we want to call this function from Java 7 or less, and then the code will be like this. I know what you want to say. Looks so beautiful, right? So, okay, let's go back. Let's go back to the Kotlin code, sorry. Okay, so Lambda expression looks good, but you might notice that here is an implicit Lambda argument. I mean, it of append function in the Lambda. You may feel it's not smart. If we can specify a receiver, it would make DSL smarter. It's called function literals with receiver. Kotlin allows to specify what is this scope of a function. Function literals with receiver is a great help for block code like builders and front style coding. If I modify the type of second parameter like the figure above, then Kotlin code can omit the implicit argument and can call append function from the Lambda directly. Because this of the Lambda is string builder now. To be honest, you can create a primitive Kotlin DSL from scratch with only these techniques. Type-safe builder is a good example. It's a good design pattern. Lambda expressions and functions with receiver will make it smarter to build entities. However, is it enough for your beta development? You may want to reject null value assignment, prevent duplicated method calls, and use non-declarative interfaces, and so on. There are still a lot of terrible stuff for DSL users. I have explained several language specifications, and hopefully you can imagine how you build very simple Kotlin DSLs. I think it's even enough if you want type-safe builders and or just use Lambda to style code. Okay, so let's dive into what techniques will improve readability and or understandability of Kotlin DSL, and how we can build Kotlin DSL for existing libraries and or APIs. Let's go to intermediate level. Features for syntactic extensions will be great help for the expressiveness of your DSL, your Kotlin DSL. Kotlin has many features to extend its syntax. I will explain 5 features with some examples. Let's see them one by one. The first thing is extension method. There is no example, but I think you all know this feature, and you understand its power. We can define new member methods without modifying existing code and or inheritances. However, member visibility restriction cannot be avoided. We cannot access invisible members like private members from extension method. The benefits of extension method for DSL are really great. Techniques in the following slides can be applied through extension method. We do not need to modify a third-party library to create a DSL for it. I think extension method is the most important and effective feature for DSL. The second thing is operator overloading. Let me take the example of KotlinX.html again. KotlinX.html represents HTML tags by block code, basically. For example, HTML with a Lambda function will become HTML tag itself. But look at the text, which is open Kotlin site in the left figure. Kotlin code is plus operator with open Kotlin site string. Not like a text function, but it's represented by text in the dormitory correctly in the right figure. This is actualized by overloading a unary plus method over string. It can represent a meaning of appending operation, and we do not need to type a long method name. This is called operator overloading. Kotlin allows overload operators like plus, minus, and so on for developers. So we can assign our own logic to predefined operators. As you may know, operators are shorter than named methods basically, and also a meaning of an operation is really clear in general. There are the benefits of operator overloading. Next is infix notation. I choose HarmQuest API as an example. This sample code is just a simple usage of HamQuest API. But this is not fluent, and also it might be unclear for non-HamQuest users. I mean, this requires HamQuest's knowledge, HamQuest's interfaces. If we use Infix Notation, we can build a DSL like the right figure. It looks fluent. I mean, it looks like English text. So users do not need HamQuest's knowledge to read and understand this assertion. Infix notation can call a function in another style. We can omit a dot and parenthesis from a method call. Infix notation would make DSL more fluent style and can reduce domain knowledge from API interfaces. Fourth technique is a method convention. This example is Groovy code. A code creates signing configurations of Android projects by Groovy DSL. In this example, debug is the name of signing configuration, and it's configured by a given closure. But debug is not an existing function which accepts a closure. Groovy will pass a closure of signing configs and create or find the debug configuration dynamically, I mean at the runtime. However, Kotlin cannot do such dynamic manipulation, unfortunately. Let's see how Kotlin code become. In Kotlin, this Groovy code is transformed to like the right figure. Kotlin cannot create a debug configuration dynamically based on a parser like Groovy. So create function needs to be called explicitly. And also, to set up the debug configuration, we need to call configure function. It may be a problem because configure function is a domain knowledge, though it's hidden in Groovy DSL. So Kotlin DSL users may need to become more knowledgeable about the Gradle than Groovy DSL users. It's nonsense. And also, the syntax between Groovy DSL and the Kotlin DSL will be different. For this issue, Kotlin DSL for Gradle reduces the burden by method convention. Kotlin DSL for Gradle uses an invoke convention from method convention. An object which implements invoke method can be called like a constructor call. So DSL implement invoke function with a Lambda to a configurable object which create function returns. As you may know, the last parameter is a Lambda, so we can omit the parentheses. This could hide the configure method certainly from Kotlin DSL users, and the syntax became similar to Groovy's one. A method convention is a kind of operator overloading. If a method satisfies a convention, then an operator or syntax which Java does not have can be used in Kotlin. For example, index access invoke range operators are famous. Method convention let us to create Lambda-based builders easily by overloading invoke. And it may be able to hide domain knowledge bypass a common operator in Kotlin. Last feature is delegation. There is an example from under the development. In under the development, API for device scope preferences is provided. It's called shared preferences. But API of shared preferences is low level. I mean, it has only simple read and write APIs. By using Kotlin, which is a DSL and a thin wrapper for shared preference API, by using Kotlin, values in the shared preferences can be accessed by delegations. It can hide shared preferences API and provide richer API. For example, it allows us save a preference when writing a value to a property through a delegation. The logic is hidden though. In delegation, a property delegates to another object when accessed. Delegates processing to another object when accessed. It may be your help to hide domain knowledge, and it's effective for don't repeat yourself when using read and write operations to properties. That's all for intermediate level. The last level is expertise level. It's related to build environments. As you may know, Kotlin compiler is extensible through its plugin system. And some interpreters which can communicate with the compiler are available. First is some with receiver from compiler plugins. Let's think some conversions. As you know, Java cannot specify a receiver of sum, but the built API may be a bit awkward in Kotlin. I mean, it might be better to use receiver in Kotlin in some cases. Of course, we have a workaround. It's an extension method. If we define an extension method which accepts a function with receiver, then receiver control will be achieved. However, it's terrible if we define many extension methods for every target. Sum with receiver is a solution of this issue. Let's see how to use it. In Java code, we need to declare a new annotation and annotate a sum interface with the new annotation. And also, we should register the annotation to sum with receiver plugin. After we compile, a parameter of sum will be receiver of Kotlin Lambda. So modifications happen in Java in the user's Gradle configuration. Sum with receiver can control a receiver while some conversions. This feature is for Kotlin, but modifications happen in Java code. This is useful if you are a Java library developer and assume usability of Kotlin DSL. And also, it may avoid a bit awkward API Kotlin. In fact, Kotlin DSL for Gradle is using this feature. Gradle's action API is heavily and widely used, so extension method workaround is not realistic. In Groovy, closure will resolve a receiver based on the resolution strategy, so there is no problem in Groovy. But Kotlin cannot do it, as you know. So Gradle team control a receiver issue by some with receiver plugin. The last technique is DSL marker from interpolators. Let's create an example of Kotlin DSL for HTML DOM3 based on type-safe builder to know how DSL marker works. In general, when building HTML DOM3, we need to take care of HTML's constraints. For example, head tag cannot be placed inside of another head tag. However, it's possible in Kotlin code, unfortunately. DSL marker can prevent this violation. DSL marker is an annotation-based configuration to add a constraint for implicit receivers. We need to define a new annotation for DSL marker and annotate receiver classes or superclasses with the new annotation. That's it. Then Kotlin compiler show compilation error correctly. Now, head method cannot be called unless the receiver is HTML class. As far as I know, DSL marker is Kotlin's only DSL-specific feature. It can add a constraint of a caller scope and can raise compilation errors if invalid. So this is required to make your DSL safer. I strongly recommend use this feature if you want to develop Kotlin DSL. And also, this is just a tip, but IntelliJ will highlight marked functions. So we should annotate functions as well. Any behavior won't be changed though. In the real example, KotlinX.html uses DSL marker, of course. You can see an error in head tag and highlighted builder functions in this figure, like HTML head body functions. Unfortunately, there are limitations for builder environment stuff of Kotlin. Compiler plugin API are undocumented, so it's not easy to develop complex logic. And DSL marker is very useful, but we need to annotate receiver classes or its superclasses. So it's basically unavailable for libraries which we cannot modify, like third-party libraries. Before closing, let's see quick tips for the DSL development. There are no differences between API and DSL in the definition, but interface design concepts are totally different. DSL is focusing on the domain and its users, of course. So DSL is kind of a well-designed API set for the domain, but also it may be limited. Therefore, we should not assume DSL can work as general APIs. Second tip is a development tip when adapting Kotlin DSL to existing libraries. In Kotlin, we do not always create a new wrapper classes for existing APIs because Kotlin has extension method. So we may should aggregate existing poor or low-level APIs by extension method first. However, if we would like to use DSL marker, then we need data transfer objects because DSL marker should be annotated to receiver classes. I mean, we need to prepare our own classes. Third tip is also a development tip. How to keep both usability of Kotlin DSL and other JVM languages. There are two cases. One case is Kotlin DSL of Java library. Another case is Kotlin DSL for other JVM languages. First case, we should use sum with receiver in Java projects if possible. In second case, we need to take care of three things. If we provide Lambda-based builder DSL, then we may need to provide method chaining interface as well, because other JVM languages might not be able to use functions with receiver. Inline features are also important. It's a feature only for Kotlin, so we need to have alternative non-inline APIs. So I recommend you split API for other JVM languages and Kotlin DSL into multiple implementation layer or artifacts. I'm sorry, I do not have any experience to create Kotlin DSL of other JVM languages except Java. So I don't know any chippers. But Kotlin DSL for Gradle would be your help, I think. If you'd like to be a better DSL developer, you should know DSL design patterns from Martin Fowler's book. And also, in appendix, I have listed up many good Kotlin DSL libraries, so please check it later. Let's close today's talk. Kotlin DSL is built from a pure Kotlin code, and it's not only for Kotlin libraries. And it's built on several techniques. I picked up several techniques which support Kotlin DSL and described them based on some categories. Techniques from language specifications are static type checking, Lambda expressions, functions with receiver. Extension method, operator overloading, infix notation, method convention, and delegation are from language features. Last category is built environment features. I introduced some with receiver compiler plugin and DSL marker. DSL marker is the only DSL specific feature, so Kotlin DSL is not a special feature, just one of API form in Kotlin. We can create Kotlin DSL for existing libraries with a few constraints like member visibility issue. And also, we may be able to coexist usability of both of Kotlin and other JVM languages if we work hard. Finally, I gathered links of books, web articles, and libraries which I had referred or recommend. Please check them later if you have an interest. Please feel free to ask me any questions at the booth of Ask the Speaker in the booth of English and Japanese. That's all. Thank you for listening.